All right. Let's start. So, in yesterday's class, we have seen replication controller and replica set, correct? So these two are used to create pods, manage them, and of course, most importantly, maintain the desired state. Desired state means whatever we have requested to create. So if I requested file, replication controller, and replication replica set as well, we try to maintain 5 pods. I mean the number whatever I gave to them, we gave to them. So here these two works for same task. I mean same thing except that the way we define the labels, that is one main major difference, because replication controller uses equity based selectors is equal to not is equal to, and this one replica set uses equity based selectors as well as set based selectors. Set based selectors mean in not in. And one more advantage with set based selectors is, see, with equity based selectors we can simply like a is equal to b, like this, one value. So let's say I have multiple labels, and out of multiple labels I want to you know filter out based on anything, any label. I have labels a b c. Out of a b c I can use anything. So it should work. So at the time set based selectors should work, because set based selector supports multiple labels, to filter out. So the replica set works on that. I mean, it will use that. We can use that, or we can use simply equity based as well in replica set. There is no issue. That's the thing. Today we'll see another topic called deployments. Deployments. Oh, deployments. Same. This is also used to create the pods, just like replication controller, replica set. The same thing. Whatever those things did, they'll create a pod and they'll manage it. These deployments also will do the same thing. But of course, there will be few differences and few advantages, a few changes with the deployments. So deployments also, when we create 5 pods, or 10 pods, anything, it will maintain that state, desired state. But it has few more advantages over replica set and replication controller. What are those advantages? Is the first one, it has rollback feature. It means, let's say I deployed a pod now. Pod, it worked for some time, maybe later point of time it did not work as expected. We can go back to previous version of the pod. What does it mean, previous version? Maybe you might have changed the image. Any change, just like GitHub versions. We store GitHub versions, right? There will be few changes for each and every version. Similarly here also, there will be changes in each and every version. So we can go back to previous version anytime if you want. So the rollback option is available in only in deployments. So whatever we do, it will Kubernetes will record that with this deployment, and we can go back to previous version anytime. Got it? So this is one of the main important feature which deployment supports. Another thing is rolling strategies, or you can say deployment strategies. What does it mean, strategies? We are discussing like deployments will create pods. I mean, it will deploy the pods. But how? I mean, usually, similarly in replica set or replication controller, it will just create a pods. But here, to create pods, there are few options, few methods, let's say. What are those? I mean, few methods is I want to create maybe let's say one by one. I told let's say 10 pods to be created. It will create one by one pod. For example, I want to have 10 pods I want to create. I'll create five at a time. I'll create five at a time. So two times. So these are strategies which we have in deployments. Why? Why? I mean, why it is required? Because with these strategies, we can use any of the strategy. We'll reduce the downtime of our application. So now what happens is when you deploy an application, with RC or RS, it will delete the existing pods and create the new ones, right? That's what usually happens. This period is the right, deleting and creating new pods. This period will is a downtime. I mean, if we access the application and whatever it's running in the pods, at that time there will be an error. I mean, the site can't read something because the transition is happening from deleting the old and creating the new. So usually there will be an sorry, there will be error. I mean downtime for the application. But with these strategies, whatever the strategies I told you, rolling strategies and deployments will help you reduce that downtime. There are multiple strategies. We'll discuss that today. Deployment is the topic today. So these two advantages which will deployment brings us. One is rolling updates, which I just told you. The strategies are there where we can able to use them to on how to create the pods. So why is to reduce the downtime or to have a very minimal downtime when we're deploying an application. Another one is rollbacks. So we can record the revisions of our versions of our application when we deploy. So we can go back to previous version anytime we want. You got it? So these are advantages that deployment brings us. So most of the people, not most, everyone, whoever is um, using Kubernetes to deploy their applications, they will use these deployments of service only, resource only, not replica set, not replication controller. Because of these advantages, this deployment gave us the strategies, the rollbacks. No other service will give these in Kubernetes, only this one. So that's why everyone uses this if they want to deploy their application. Got it? So let's see. Oh, sorry, I forgot one more thing to say, important thing. So internally, I told you deployment will create pods, obviously. So what happens, right? It won't create the pods directly. It will create a replica set, and replica set will create the pods. You got what I'm saying? So when we deploy in the backend, deployment will create a replica set, and the replica set will create the pods. So deployment uses replica set in the backend. So you don't need to use replica set separately if you want to deploy your pods. Why? Because I mean we can simply use the deployment. We'll get the deployment advantages as well as replica set is being used internally in the backend. So we can have both. Got it? Now let's see, you know, how this deployment file looks like. First, let's. I got stuck. Okay, let's come meanwhile. So as I told you, right, all the changes will be above only. I mean, in the API version kind. Uh, Below the templates, nothing will change. Come on. Yeah. Super. So this is the replica set file. I told you yesterday, these won't change. This is your requirement for creating pods. These will change. Only these part will change for every resource because that's we're just changing the type, the resource type. I mean, and whatever the options to the resource type. But what is the task overall? We're to create pods. That's why the below part didn't change because replica set, replication controller, and deployment, all these things will be is used for the same purpose to create pods with a few differences, obviously. Okay, I didn't copy it properly. Let's copy. What the hell? Okay, let me copy again. Mhm. Control C, copy. Go here, paste. Ah, it came finally. So only this will change. Template won't change because just the pod template which we are creating the pod. You can remove one container if you want, or you can keep it. There is no issue. Depends on the requirement. So first thing, kind apps. API version is same, so it's fine. Apps is kind is deployment. Deployment metadata change anything test to deploy. And here spec is fine. Replicas okay. I want five, maybe three for now. Just why to run five. Selectors now it will be match labels. Match labels. We are just using you know what is that? Set equity based selectors. I mean we can use the set based selectors just like the expressions here, but we don't want to use it. Why to have this confusion? Just use simple one equity based selectors. Got it? That's it. These are deployment file. Of course, there are a few more things, but this is a simple deployment file. Shall we try deploying it? Simple. What do we do? Same thing. Just copy paste. Let's check the syntax. Okay, it's correct. Control C, Control V. Deploy dot yes. Paste it. Yes. Control V. Save it. kubectl get PO. There is not. There are running replications that is running. Okay. Let it run. kubectl apply -f deploy enter. Bad request for creating deployment motion can be handled deployment as much. Wait. What did I do? Oh, sorry. You know what is the wrong? Match labels. I forgot to give capital L. Those are very important. Now it should go. Oh, sorry. So it's created. kubectl get pod. If you'll see, so yeah, deploy pod which are just it will create. It will take time, but it will create. See running. Now to see the deployment, kubectl get deploy. See deployment test deploy is available. kubectl get rs replica set. If you see test deploy replica set, I told you right. This is the old one. Yesterday we ran it. Forget about it. This, if you remember, test deploy. I told you. So deployment internally uses replica set. So when you do a deployment, it will create a replica set, and uh, and the replica set will create the pods. That's how it works. Now, is it clear so far? How to write a deployment file and create it. Now I told you there are two advantages, right? One is recording the versions of deployments. What is the other one? Mm, rolling strategies. First, we'll see recording the versions, how it will work. So we also call them rollbacks because we can roll back to previous versions. So what happens here is a rollback. We can say with a command. The rollback will be we can roll back with a command. How to do it is let's ctl delete hyphen f. Let's delete it. Let's create again. ctl delete rs. Let's delete this also. Okay, got it. Now kubectl apply hyphen f deploy hyphen f record. Hyphen if I pass hyphen f record, this record only works for deployment. I mean whatever I gave here. This will start recording the deployments. What? Flag, okay, it has been deprecated. It will be removed in future. Okay, maybe that's fine. For now, it will work. Now, deployment is created. First thing, check get a deploy. Deploy is created. Get PO is pending. Let's wait. It will take some time. Don't worry. Usually, it got stuck, but that's okay. Let it run. kubectl get rs. Okay, replica set is created. If you have doubt, let's say now why it is pending. Describe pod slash the pod name. This is the one, right? This is pending. Untold anything. Fails are dealing because it did not want so unknown has untold at 10 untold games. Oh, it. See, it became not ready. Why? Check once. One thing is, what I say, it's just 1 GB. It's crossed. First, let's do one thing. Sorry. I know it will go down. But just very simple server. Let's uh, let's delete the deployment first. We have to delete all these things forcefully. Paste PO slash paste. Yeah, all are gone. Still not ready. So now what we do? Let's log into the machine first. Let's see what is there. Yeah, I get it. It's out of memory. Okay. So that's why I had to increase it. That's why you can't even log into the machine. So let me increase the memory then. I had to stop it. Just for 8 parts, it can't even handle. Come on. It's let's wait. Let's wait. Still stopping. How much time it will take to stop? Just come on. One machine. One machine. Just 1 GB machine. You can't even stop. See? We cannot change it unless it's stopped fully. It's blocked. Let's wait. Let's wait a minute. Meanwhile, let's come back to our class. We'll explain this. So this is our thing, right? As I told you, with this command, sorry, what is this? Hyphen force. Sorry, not force. Hyphen record. So this command will store the revisions for your deployment. Let's say first time I'm deploying, it will store your state, like whatever you created, it will store it. Maybe let's say the second time you might have changed the image, you know, the image name might have changed, or your image version might have changed, or you added one more container. Anything, any change after this template, let's say the name change or labels change, containers, one more container is there, I told you, right? Or port change, version change, the container names, anything, any change after this template, it will record it. The above is just for deployment, right? This won't record. The changes which will happen after this template only, it will record. Now let's say I changed maybe some name. Now let's say container version, the image name I changed to some different version, and I can record it. Now what happens? It will store the revision. How it will store the versions of your application based on the revision numbers, or revision 1, revision 2, revision 3, revision 4, like this. Of course, 1 being the old, the 5 being the latest. I mean, the highest number is the latest. So if you want to go back to any version, you use the version, the revision number. But you do have to remember what you have changed it. So otherwise, it will be difficult. So you just use the revision number, and you simply, tell to Kubernetes that, hey, I want to go to this revision number, and it will go. There is no, if the revision number exists, it will go. Let's say I have five revisions and you give 10, revision 10. But the 10 revision number is not exist, right? It won't go finally. So let's change this instance type maybe to, see, just 1 GB mission. Maybe T2 medium, or maybe large. Yeah, that's okay. Blah, 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 blah. As instance state, start instance. So just now it will take 1 minute. So yeah, coming back to our rollbacks or storing the revisions. So we can store any change whatever comes after the, as I mentioned, and it will store as a revision numbers, and we can able to use those revision numbers to go back to our previous versions of our application. You know, got it what I'm saying? Let's try that. Let's on server is up. Let's try that. Ah yes, you see it's working. Earlier it was throwing an error. kubectl get notes. See now this is ready. Yeah, okay. Usually happens sometimes, but because it's just 1 GB memory, I ran almost 10 to 10 pods or 8 pods. It couldn't able to handle. That's normal. That's fine. So now let's come to our class. kubectl deploy. Sorry, my bad. Apply. There is no command deploy fnf. There is a command, but yeah, let's sorry. Apply fnf deployment. If I execute this, it will deploy it, but it won't store the revisions, the versions. Only if I do this record, it will store the revisions. kubectl get pods. Of course, pods are created. Maybe we have to decrease the count. That's okay. A replica set also will be created. Obviously, deployment also created. You've seen it. Now I gave record. It means the role revision might have stored it. How to see? kubectl rollout command is there. Rollout history deploy slash. What is the deploy name? Test deploy. See the revision number 1. But this is the command we gave. Now let's say deploy. I'll change something. I told you right. Whatever we change here only will store in the revision number. I'll change the replicas also. Just I don't want them to be running 3, maybe 2. So below template, maybe I'll change Tomcat 8, maybe just some change I'm doing. Now if you kubectl, what I'm getting deploy, apply hyphen here, deploy.yml hyphen record. I changed it. I deploy the new version while recording. Now rollout history. See now 2 are there. In 1 we deployed at the beginning. In the version 2, what we did, we changed the Tomcat image name. That's what, right? Check the pods. Pods are running 9 seconds, 17 seconds. How do you know whether the change is applied or not? Whatever the version change, describe the pod. It will show you the image, right? Which image is being used. Let's try. Successfully pull Tomcat image 8. See, that's all. That's all. I mean, usually I just changed it. Now I didn't like it. I want to go back to Tomcat 9 only. So one way is simply you can just simply come here and change it. That, or another way is rollout history is there. Deploy slash, what is the deploy name? Test hyphen deploy. So rollout history is there. You can go back to revision one number one. That is also fine. So just updating the file, opening the file, updating the file, that's okay. Maybe not a good approach because maybe at some point you don't know what changes you have made, maybe But with revision, it will store you. All you have to do is just save your revisions. In one, this is the change. In two, this is the change like this. In not just two, you can create one any revisions. Let's open that apply. Maybe I'll change the container port 8088. Test to Tomcat. I'm just changing everything. 8080. Test engine. Now, whatever these changes happens, that will store as a new revision. Apply record. Rollout history. Okay, third revision. How do I know? kubectl get po. Test deploy is there. kubectl describe pod slash anything. Just copy paste it. These are all fine. Tomcat. This is fine. Scroll up. Test Tomcat. See the name is changed. Test Nginx. The name is changed. See port number Nginx port number 8080 I gave. See Tomcat port number 8088. So like this, any there is no limit for. I'm just trying to say no limit for revisions. You can have 300, 3000. Of course, we don't go that far, but yeah, we can read. Now I made so many changes. I want to go back to my original one, or I want to go back to second revision. Any version. What is the command is kubectl sorry rollout. We just now seen rollout history, correct? Rollout history. Deploy slash test type deploy. See, this is the history. As I told you, you can't see here what's inside. Let's say you can't see what changes here, what changes here, what changes happen. I want to see the changes. What happens? What you do? Rollout history. Apply the deployment name hyphen revision is equal to 1. It will show the ML file. See like this. So based on that you can see. Or revision 2. It will show you the ML file. See what changed? The image. See, or revision 3. See the what changed? Port number, names, blah blah blah. These things. See, observe like that. You can see the content. So simply rollout history command only. Normal history will show you all these things. If you pass a specific revision number like this, it will show you same command. If you observe same command like this. Except that I'm passing revision number, it will show you the contents of that specific revision. That's it. Correct. Now I have seen the content. I want to go back to revision 1. How to do it? kubectl rollout history undo. Undo is the one. Rollout history, the deployment name if you give it will print you. Rollout history, the deployment name, the hyphen F1 revision number, it will give you the contents of the revision. Undo will go back, revert back, roll back originally to the revision numbers. Sorry. Deploy slash test hyphen deploy hyphen F1 revision. Sorry, hyphen F1 2 revision 1. See the command change. It's all present documentation, so don't worry. It's pretty static command. You'll remember it. 2 revision. revision. Correct. Wait. I gave the wrong. History command won't come here. Rollout history, rollout undo. These two are the commands. There is a command rollout history undo. My bad. Sorry. Spelling mistakes. Yes. It's rollback. kubectl get PO. It's running. How to check? Describe it. Describe any pod. You have to see your, whatever we have in the first. What we have, the test 1, test 2 names, Tomcat 9 image. Let's take this pod. Paste. Yes. Successfully Tomcat 9. Scroll up. See test 1 container. test container. These are the original containers we have with Tomcat 9 image. Observe here. See, it rolled back easily. Got it? That's how easy it is. That's how easy to roll back. Got it? That's faster it is if you observe. Got it? Is it clear so far? How to create deployment, how what or what is it, how it works, and what is rollback strategies. Got it? Now let's come to another advantage. As I told you, deployments provides another advantage, which is called strategies, rolling strategies. I mean, the way we deploy the pods, we can change that. Of currently now we're just having two pods, so we're not seeing, just no, we're not seeing the change. But usually, let's say we have huge pods, the bigger applications. Usually, it will take time. Of course, the delete and recreate. That's what usually happen. Delete and create. But of course, we will have a downtime. So in order to don't have the downtime, what we do? So we have strategies where we can able to use. Where to use the strategy? Simple in deployment file. Let's not write here. Let's put here in deployment file. After here, after strategy, sorry, after replicas, we define the strategy. TGY type. Now here we have to define what is the strategy that you want to use. There are multiple strategy types. We'll go with one by one. So first strategy is rolling update. Rolling update. Simple. This is the default strategy when we create a deployment. We don't need to specify it actually. So what will happen here is it will replace, updates few replicas at a time without the downtime. People use this rolling update strategy. So what we do here is, of course, we have two more options which we need to write. We are limiting how many parts are updated at a time. Let's say I have 10 parts and I want, two parts to be deployed at a time. I mean, two parts to be deployed means updated at a time. So let's say I deployed a pod now. 10 pods are running currently. I mean, I deployed deployment, 10 pods are running. If I do deployment again without a strategy, it will delete all the 10, it will recreate all the 10. Of course, it will be an issue for me, right? So what I want is deployment 10 pods are running, fine. Now when I update something to the deployment, it should delete two pods, update two pods, delete two pods, update two pods. Like this, some pods will be running to, it will be always upright. There is no downtime. You got what I'm saying, right? So this strategy will help us, like, limiting how many parts are updated at a time. Let's say 10 is there. I gave 5 limit. It means if first it will delete 5, other 5 will still be running. It first delete 5, create 5 new, I mean, in the place of them, and delete the next 5, create the next 5. So like that, the batch wise it will be happening. So here what happens is, like, if I delete 5, the remaining 5 will be running, so there is no downtime. Got it? So how easy it works is type rolling update. Rolling update. There is thing called max surge. I'll explain that maybe. Don't worry. Max unavailable. 1. Sorry, 1. Yeah. As an example, what is max surge is, this will define how many parts can be created above the design number. So let's say, what does it mean? How many extra parts? Why? How, I just said like how many parts can be created above the desired number of replicas. Why we need to create the parts? Because what happens is when you deploy a new version, let's say in the deployments, first it will create the parts and it will delete. Correct? That's what usually generally happens without this strategy and all. So it will create two, delete two immediately. But now here with the rolling update, what we did, we are limiting how many should be deleted, how many should be updated at a time. So now 10 pods are there. I told 5 pods to be created. I mean 5 pods to be updated at a time. So first it deployed the 5 pods. Once it is running, it will delete the 5 pods. If you observe here, the old 10 pods are there, and of course the new 5 pods are running. Just for some time, very less time, 15 pods are running because we define like that. Do update 5 at a time, not everything at a time. So this max search, what it will do is, if one is present means it will make sure one extra pod is created. While updating this to handle, and once that is done, it will delete the extra pod. I mean there won't be an extra pod. Same way here, max unavailable. Here we are defining one pod is allowed to be unavailable during the update. Only one pod. It's a 5 I gave. So while deploying, I mean the new revision, 5 parts can be unavailable. So it's fine, no problem like that. Out of 10, 5 parts can be unavailable. Or if I give 2, 2 parts can be unavailable. I mean 2 parts can update. That's what we are giving the change. The change here. So one is max search, another is max unavailable. Max search is like, how many additional parts can be created above the desired number of replicas, whatever we define. Because the limitations we are giving, because we are trying to deploy this as batch wise, so that's how we do it. And max unavailable is maximum how many parts can be unavailable, can be down at the time of update. So one or two, whatever, based on your requirement. This is the rolling update strategy. Simple copy paste. You may not see, sorry, you may not see the complete change here because we're just running 2 parts and the parts are creating very fast. So you may not see the change, but let's try. kubectl apply -f deploy. Wait, deployment version cannot be handled, specs editor match labels. My bad. I forgot to change the L. Got it. Created kubectl get pods 3, okay. Now open the deployment. I just want to change it. Let's give it 2 because otherwise, the issue is happening. Maybe change Tomcat 8. I'm just updating without recording or anything. Just updating. Now what happens? The changes happen. It will follow this rolling strategy to update the change. Let's see if we can see the example. See, by the time we open, it's creating. I told you that the parts are creating very fast. We don't see example here. We have to figure out a way to see the, whether it's working or not. When we have huge pots, when we have larger, big pots. That's how usually. So here, where is this? Yeah, let me go here. Here, you can give 0. So what happens is, it will be with completely 0 downtime. What does it mean 0 downtime means? No part, what is max unavailable? No part should be, present. Sorry, no parts, how many parts should be unavailable, can be unavailable? at the time of deployment. We give one means one part will be down when we're deploying it. If we give zero, no parts will be unavailable. Should be, can be available during the update. So every pod will be running. So what happening here is if I give zero all pods running, I told without any unavailable pod. So what's happening here is once it will make sure that all the pods are ready until the new ones are fully created completely. That's all. Got it? That's how usually it will happen. So you got it? What is rolling update? Any doubts? This is one of the strategy or let's say default strategy people use. And there is one more thing called a recreate. You can simply remove everything. Strategy type recreate. This will do the same thing like what happens is this will delete the existing pods before starting the new ones. Vi deploy 1990, sorry, my bad. So it will delete the existing pods first and create the new pods. So no one uses this, and obviously because you know the issue. We cannot delete the existing one, we cannot create new ones, which is not a good approach. But people follow this. People follow that. That's okay. So, but yeah, no one uses the recreate. But I'm just telling you, got it? There is one more thing, or there are multiple things. I mean, two more are there where strategies. One thing is blue-green strategy, and another one is canary strategy. So usually how blue-green works is general deployment strategy. This is not just for containers. Everywhere people use it. So what they do is, so I'm explaining because just giving give brief for now, just for now. We'll see that later, but just today I'm giving you a brief. So what happens is like currently deployment is running, right? I'm running containers in the pods. It's running fine. Now what happens here is, let's say I'm using blue-green approach and I deployed my I mean, the pods and everything. How this blue-green works is first it will deploy the new version. First it will deploy the new version. So let's say currently there is running two pods, so it will deploy the new version. So and the old version still be running. So usually what happens is rolling updates or recreate. Recreate, let's say it delete everything and create again. Okay, then remove that. Rolling update also, it will be deploying batch wise. I mean like I told one at a time or two at a time. So it will be batch wise, one by one or two by two. But this this strategy, whatever the blue green strategy, it will deploy the new version uh, along with the old version. Now, the old version still be running. It will deploy the new version. So now we have two versions of applications running in the cluster. One is old, one is green. Sorry, one is latest. So blue is the old version, we refer it as. Green is the new version. So two versions will be running within the machine, within the cluster. Sorry. Now what happens is, if let's say everything is fine with the new version, all are good with the new version, no issues, then old version will be deleted gradually. So the traffic will point from old version to new version. Got it? So here at one point, for some time maybe until the new version is okay, healthy and everything. Until that point, old version also will be running. Like, sorry, anyone have any doubt? I see someone unmuted. That's why. Sorry, let's continue. So what I'm saying is like we the old version also will be running along with the new version. Even after deploying the new version, old version will be still running. Once the new version is fine, everything is okay with the new version, then the traffic will point from old version to new version, and the old one will be deleted gradually. So here at one point, we have two versions of application running in the cluster. So what happens here is with to to overcome the downtime, usually we use this. Most people use rolling updates or blueprint, any of these. Got it? So blueprint is not just for containers. It will be used in multiple deployments, even normal Linux server deployment, any deployments. People use this. So that is one of the approach we have. Another one is we have called canary deployments. Canary is something. I mean, I never used canary, but I mean, as of now, no use, never used. But I know what is canary. Maybe I'll try to explain to you. Even Kubernetes I never used. So canary is either people use blue green deployments or rolling updates. These two are the things. But for just for interview sake, at least just for knowledge sake, know this. So canary deployments is like what happens is I have 10 servers, let's say. Example is for 10 pods here. So the new version, we're deploying the new version, right? It'll this also little batch wise. So the new version will be deployed maybe for half of them. Let's say out of 10, the new version will be deployed for 5. 5. Remaining 5 will be running the old only. Once this new version is fine, I mean the 5 containers, 5 pods are fine, working fine, it will roll out the remaining changes. Like a batch wise, most kind of batch wise. It will apply for some set of things. Let's say, to keep it simple, 10 servers are there. When we use Canary, it will deploy to 5 servers or 3 servers based on our configuration. If those 3 servers are fine, working fine after we deploy the new, I mean the changes are working fine, then the same change will apply to other things also. That's how. That's how Canary works. As I told you again, I never use it, but it's good to know, right? Even though you don't use it. So these are the main strategies we have in deployments. Rolling update, recreate, blue green, and canary. Got it? Is it clear? I mean, is it clear about the, you know, what I'm saying, the deployments, about the rollbacks, about the strategies? So is it clear? The blue green one we'll see maybe tomorrow because I'll show you. You need to know some one more topic further. Let's see tomorrow. Okay. Read out so far today. Tomorrow we'll see.
Once
Yeah,
practice.
two topics, very small topic, but yeah, it'll be good. Yeah, tell me, sir.
Practice అయ్యాక
Yeah, do practice and yeah, let's see. Got it? Let's meet tomorrow, same time, 7 a.m. Try to join early. Don't 7 means don't wake up at 7. Just join by 7:10, something like that. Try to join before 7:05, 5 minutes. I mean, before 5 minutes means at least 5 minutes.
okay.
7:05 is okay, but 7:10 so might be late for us. So try to make sure that. Got it? So yeah, let's meet tomorrow then. Bye. Bye all.